Hello everyone, I am Tarun Valireddy. Welcome to my channel. Today in this video I am going to show you how to implement this actual VPC architecture in the AWS. Before going to implement this in the AWS, let me explain you what we are going to implement in this video. First we will create a VPC that having public and private subnets in two availability zones. In the private subnet we are going to deploy autoscaling group. By using autoscaling group we deploy two servers on the private subnet and we don't provide any public IP to these servers. So by using the NAT gateway we are going to access the internet to this private subnet servers. In the public subnet we are going to deploy an application load balancer. This will balance the load between these two servers in the private subnet. Instead of S3 gateway, we actually use a Apache server or a Python based simple HTTP server in this video. Let's try to implement this in the AWS. Open the AWS console and search for VPC. You can see here isolated cloud resources. Click on the VPC and now let's create a new VPC, create VPC. Here we can see that it's already shows a VPC that is being created if we seek this option VPC and more, or otherwise if we choose VPC only we need to create everything individually like route tables, subnets and internet gateways, but I'm going with the VPC and more option and I am leaving the default CIDR block to the /16 and we will get around 65,000 IPs. And the availability zones that I am using 2 and the number of public subnets leaving default like 2 and number of private subnets are also being 2. Now we need to select the NAT gateway. The AWS introduced a new option that recently updated. If you want to choose a zonal, like if you want to navigate for each or the availability zone, or we can choose, otherwise we can choose a single NAT gateway which is useful for both availability zones. So I am choosing only one NAT gateway for both availability zones. And as I said in the previous, I'm not going to use the S3 as an endpoint, so we are using S3 instead of Apache server or in a simple HTTP server. And now click on create VPC. It's going to create all the resources. It only takes some time while creating the NAT gateways. After creating the NAT gateways, we're going to create autoscaling group on the private subnet. Let's give it some time to create the NAT gateway. And also make sure that after completing this demo, please delete the VPC, otherwise it will charge you. Please make sure that after completing the demo, please delete the VPC and the NAT gateway. Especially we need to delete the NAT gateway, otherwise it will charge you. Any other resources like internet gateway or the subnets don't charge any. Now we can see the VPC is successfully created. Now we are going to create the autoscaling group on the private subnet. Click on home and search for autoscaling, or we can access it in the EC2 instances. So click on EC2 and scroll down, we can find here autoscaling groups. Click on autoscaling groups. create auto scaling group. If we want to create auto scaling group, we need launch templates to what the requirements we are going to instance that are going scale down and scale up when the requirements are needed. So before going to create the auto scaling group, we need a launch template. By clicking on the create a launch template, we can create a new launch template for the auto scaling group. Now we need to provide the name for the launch template. Auto scaling group launch template, provide the name for the testing the private subnet servers. Now we need to choose which image we want to use in the instances. Now I'm going with Ubuntu, and we need to select the which instance. I'm choosing T2 micro and the key pair, and that's it. We can create launch template by clicking on the launch template, create launch template. We can see here the launch template is successfully created. Now we need to click refresh to get the, now provide the auto scaling group name, auto scaling demo, auto scaling group. Now choose the launch template that we are created. Now click on next. Here we need to choose the VPC that we are created, that is demo VPC, and the availability zones that we need to deploy the auto scaling group. And as we mentioned, the auto scaling group must be in the private subnet, so make sure to choose the subnets that are in private subnet 1 and private subnet 2. Now click on next. Actually we are going to use the application load balancer, but I'm going to create that in the public subnet. I'm not going to attach here. Now let's click on this health checks and click on next. And here we need to mention what is the minimum and the maximum desired capacity we are going to use. The minimum I'm going with 2, and the maximum that are 4. Now simply click next. Here we can see what are we going to create by using this auto scaling group. Now click on create auto scaling group. You can see here the status is updating the capacity. After it was becomes 2, see here it was successfully created the 2 instances in the private subnet. We can check. Click on the EC2 running instances. We can see here 2 instances are created by using the autoscale group. If you check, this instance was in the private subnet 2 and this instance was in the private subnet 1. Now we are created the servers on the private subnet, but if you clearly see here, there is no public IP is assigned to these instances. But how we are going to connect this to the servers? Actually I forgot to mention while I'm explaining this. Deploying the application load balancer, we actually need a bastion host or the jump server to connect these servers in the private subnet. If we want to access any servers that are in the private subnet, we need to create a jump server or a bastion server public subnet. By using that private, by using that jump server, we're actually connecting to these private subnet servers. So let's try to implement the or deploy the jump server on the public subnet. Now click on dashboard and we're going to launch the bastion host or the jump server. I'm using Ubuntu, same as like private subnet servers. T2 micro. If you don't have any key pair, try to create a new pair. And this is important. Try to edit the network settings by clicking on the. We need to choose the demo VPC. The bastion host or the jump host should be in the same VPC to connect to the servers in the private subnet. And auto assign public IP enable. And that's it. Click on launch instance. See here, we are able to get the public IP address to this jump server. Copy this. Let's try to connect the servers that are in the private subnet by using this jump server. For that, open the. I'm using Mobile Extreme. We can use whatever the favorite terminal you want. See, I am able to connect to the jump server. Let's update the packages. But if you see here, we need a key pair. If you see here, the private instances doesn't have any public address, so we need to connect by using the key pair only, right? So we need to copy the key pair from the local machine to the jump server, then we can connect to the private servers. Let's try to copy the by using this command secure copy. Try to provide the path where the key pair was available, and after that we need to provide the username and the public IP of the jump server and provide the path. We can see here the key pair was copied successfully. Now we can check the key pair was in the jump server. Now try to connect to the private servers. SSH Ubuntu. The rate. We need to provide the IP address of private IP address of the. Here we can see I'm trying to connect the server that is available in the private subnet one. Click enter. Sorry, I forgot to provide the test key pair. Now we can see we are able to connect to the. Now click on enter. We can see that it asking for the confirm, click type as, and we are able to connect to the instances that are available in the private subnet. We can check here the private IP of the server 1. Let me show you. See here 10.0.142.82. This is we are connected. Like this we can connect to a server that is available on the private subnet. Now let's try to deploy the application load balancer that balances the load on the both servers that are available in the private subnet. Let's try to deploy the application load balancer on the private subnet. For that, choose the load balancer and click on create load balancer. There are mainly three types of load balancers, but in this video or in this demo we are going to use the application load balancer. Whether which server is healthy, the load will be transferred to that server. Try to give the name of load balancer. It should be internet facing, and after that make sure that choose the VPC that was demo VPC and the availability zones. We need to deploy it on the public subnet, so we need to choose the subnet as public. Make sure to choose the public, then only it will be transfer the load according to the healthiest. I'm using the default security group which can able to access the Apache server like port 80, which is open to the port 80. If not, we can add the port to the security group after. And one more thing is we need to create a target group for this load balancer. Target group is actually used for which servers we actually need to route. For that we need to use target groups. So if you have any existing target groups we can use, or otherwise we can create a new target group by clicking on the create target group. So try to give a name. Here I'm using demo VPC target group. Provide the port 80 and then choose the VPC demo VPC, and we can leave everything as is and click on next. It says already available. Then try to change the name target group, click on next. We need to choose the which servers we need to route. So we need to route the traffic to the instances that are available in the private subnet. So I am choosing both. Try to click on this include as pending below, and now click next. Now create target group. After creating, it says that 0 healthy and 0 unhealthy. Now try to again refresh to reflect the changes that are made to the target group. Now again try to give the name demo load balancer and choose the VPC demo VPC and choose the availability zones, and that should be in the private and that should be in the public, and choose the default security groups, the port 80. Here we need to select the target group that which are created. That's it. We can create load balancer. After that, we can see the load balancer is provisioning. After it completed the provisioning, we are able to access the applications that are deployed on the private subnets by using this load balancer DNS, by using this DNS name. First it says that it's not available. After, by using this load balancer DNS, we are able to access the Apache servers. Let's try to deploy the Apache server on one EC2 instance. It's still in provisioning. Before it going to complete the provisioning, let's try to deploy the Apache server. Install Apache 2. Going to be install the Apache server, and after that start the Apache server. We can see here the Apache server is started and it is running. Now we can see, I think the load balancer was completed. It was active. Let's give it some time to load the Apache server, or try to open in a new tab. Load balancer and choose the DNS. It's still loading. Let's wait for some time. Actually, I forgot to open the port of 80 in the security groups. That's why it's not opening. After opening the port of 80, you can see here we are successfully able to access the Apache page by using this load balancer. See, try to add the port of 80 by clicking on the edit inbound rules and add the port of 80. We are able to access. Let's try to change the content in this. Hello, this is from server 1. I'm copying this to try to use the sudo. You can see we're able to get the response from the server 1 Same like this we need to implement on the server 2 also. For that, open the EC2 and get the IP of the instance 2 and try to connect, exit from this and try to connect to the server 2. Enter, click S, we are able to connect. Same like that we need to install the Apache server. So Apache 2. After it going to install, let's try to change the index file of the default Apache server. Echo hello, this is from server 2. Now we are able to, when we refresh this, we get two things. Let's try to close and get the load balancer DNS, copy. When you refresh, actually we are getting one thing, but if we go and check the health of the both servers in the target groups, let me show you what I'm trying to explain. Here we can see it actually shows one is healthy, but let wait for some time, it will show you the second thing. Second server also healthy because we are deployed Apache 2 on the second server also. Let's try to check here. Curl local host 80. Yes, we are able to get the output. Let's wait for some time to reflect it. Otherwise, try to open in the new tab. We're able to see the two servers are successfully configured by the Apache server, and when we refresh, the traffic is transferring both server 1 and server 2. We can see here. Like this way we can, by this way we can deploy a VPC architecture by using private subnets and public subnets. And if you really like my explanation, please like, share and subscribe to my channel, and thank you for watching this video.